we have not talked much about mixed exponentials. And by that I mean some exponential function times some other function, like x times e to the negative x. We're not going to spend a whole lot of time on these, but I think it's useful just to talk about these graphs briefly so you can see what the key features and characteristics of exponentials are versus polynomial functions that we're more used to. So if you look at these graphs on the right, there's a couple here that I would call very, very familiar from what we've talked about with exponentials. So this guy right here, this guy right here, those are more vanilla, right? They're like e to the x and e to the 2x type curves. One of them steeper than the other, and that's the giveaway. Okay, so this one is e to the 2x because it rises much faster than this one over here, which is just e to the x. And then we've got some other curves that I would just want to highlight that look also very much like normal exponentials, but they're going backwards, right? Instead of starting at 0 on the left and rising up to infinity on the right, they go in the other order. So you should recognize that as a horizontal reflection, okay? And that's e to the negative x and e to the negative 2x, where the steep one is e to the negative 2x, and the shallow one, the relatively shallow one, is e to the x. Now, once you've categorized those as the normal exponential curves, those are pure exponentials, then we have these other things that are just thrown in for funs and giggles here. We've got some bumps in there. And notice that all of them actually hit 0. That's important. No normal exponential or pure exponential will hit the value 0. 0 is on the horizontal asymptote, and they would normally approach it but not actually reach it. So we've got some things here that are interesting, and I want to talk about, let's say this one right here. On the right, that looks like an exponential function. On the left, look at what's going on here. That looks like it's gone negative. So which one of these polynomials would match that function? Well, you can't have a negative over here without some kind of odd function behavior. So I'm thinking this is going to be x times e to the x right here. X times e to the x. And a couple of points should serve to explain why this is happening. If I say y equals x times e to the x, and I plug in negative 1, well, look what we get. We get negative 1 times e to the negative 1. Now, e to the negative 1 is some decimal value, right, which multiplied by the negative 1 gives you something negative, right? That's some negative kind of something. Whereas if I had done, for example, something a little different, if we had said y equals x squared e to the x, plug in negative 1, what happens? Well, we get negative 1 squared times e to the negative 1. That would just be e to the negative 1, which is positive. And that negative versus positive is the main difference between these two graphs right here. You can see why this one would be x squared e to the x. Because of this bump, it can't go negative because of the x squared function that's preventing it. That's an even function. Or at least the x squared portion of it is even. And now if you look at the other two graphs, the ones that are left, there's not much to narrow down at this point. We've got a bump in one of them. That's the giveaway for an x squared behavior. Okay, this is x squared e to the negative x. And then in the other one, this very last one, am I running out of colors here? Well, look at that. It's going negative again. And remember, the only way an exponential can go negative is if there is some kind of odd function multiplied against it. So in this case, that would be x times e to the negative x. Kind of interesting why these curves look a little more different in this case. And you can run through a few points and see if that makes sense when you plug in numbers. But essentially what we're doing here is we're trying to say, listen, we've got a certain type of behavior. Okay, I'm just going to use e to the x as an example. You've got a certain type of behavior when x is positive and a different type of behavior when x is negative. And when you're multiplying two functions together, that becomes more apparent.